So in this video, I'm going to be going over this one integral of x over x squared minus 4 dx. I'm going to solve it 3 different ways though. This is just to show that a lot of times more than one technique of integration works. However, you'll see clearly that one technique is much more efficient than another, even though all 3 of them can get to the exact same answer. Okay? So let's begin. We have the integral here. Once again, it's x over x squared minus 4 dx, okay? Immediately, I could see a substitution can be made. All right, so we just let u be x squared minus 4. du is 2x dx, okay? So x dx is du over 2, or half du, and x squared minus 4 is just u, so our integral becomes this right here. This is just a natural log, so it's half ln of absolute value u plus c, and then when we back substitute, so it's half ln of absolute value x squared minus 4 plus c, and that's your answer. This is the most efficient method of the 3 that I will show here. Okay, that's method 1. So hopefully you're able to see the substitution. It's actually quite simple to see if you got enough practice. Okay, if not, you can use partial fraction decomposition if you really wanted to. Okay, the bottom we can factor as x plus 2, x minus 2, okay? So we can break this up into a over x plus 2 plus b over x minus 2, okay? I won't go over the details of why it's like this. You can watch my other videos to see that. Okay, so multiply both sides by this denominator, you would get this line right here. We plug in nice numbers like x is 2, then we get b is half. We plug in x is negative 2, we get a is half as well. So we found these 2 coefficients. We can rewrite this integral as half times 1 over x plus 2 plus half times 1 over x minus 2. Okay? These 2 are just natural logs if we integrate. Okay? This is not the same as this. Did we do something wrong? No, it's exactly the same though. We just have to do some algebra. Okay? So I factored the half from these 2 logs. Okay? Now I use properties of logs. ln a plus ln b is ln of a times b. So this should be the absolute value, by the way. Okay, pretend more straight. Okay, so half ln of x plus 2 times x minus 2 inside the absolute value plus c. Okay, and this you can simplify to x squared minus 4, and then you get a matching answer. Okay, so it's deceiving that if you use this method, it looks kind of different if you just stopped here, which is technically the correct answer. But to get it exactly match what I got up here, you have to do some algebra. Okay? And now method 3, everyone for some reason doesn't like this technique, or not everyone, a lot of people. You can do a trig sub. Why are you able to do a trig sub? Well, it's a something squared minus something squared. Hopefully you've seen my other video. If not, I would recommend you watch that on that crash course on trig sub. If you see a something squared plus or minus something squared, you could probably do a trig sub. Okay? So we set up the triangle. I won't go over the details, so again, go watch that video, please, if you are not familiar with trig sub. So x is 2 secant theta, dx is 2 secant theta tangent theta d theta. And then we need x squared minus 4. How do we do that? Well, we can substitute in this triangle. We can get, in this triangle, we can get the square root term. So square root of x squared minus 4 is 2 tangent theta. Square both sides, so x squared minus 4 is 4 tangent squared theta. We substitute everything in this integrand in terms of our new variable theta. We get this over here. Start simplifying, so this 4 and these 2 2's would cancel. 1 power of tangent would go away on the bottom. Okay, so we have secant squared theta over tangent theta d theta. This is just a simple substitution again. Let u be tangent theta. du is secant squared theta d theta. So our integral becomes du over u. This is just ln of absolute value u plus c. And we got to back substitute twice. ln of what's u? Tangent theta plus c. Okay, and what's tangent theta? Well, we had this definition over here, or we can get it from the triangle again. This is what we get. Again, doesn't quite match this. So what happened if we had stopped right here? Again, we just gotta do some algebra. ln of a over b is ln a minus ln b, properties of logs, okay? This is just some constant. We lump it in with this constant c, okay? And then this is x squared minus 4 to the half power. That half we can move out in front of the log. But again, properties of logs. This is just algebra. So now we get a matching answer. Okay, technically this would have been correct as well, again, but to show that it's matching the other answers, I did some algebra, okay? So again, the point of this video is to show that a lot of times, more than one technique can work. Okay, there's probably many other techniques that you can do. Maybe you can even do integration by parts technically. Or this is the technique that I don't use often. I just see a lot of people for some reason do it in other countries. They might do a -4 and then +4 or something like that on top. I don't know. This is some weird algebraic hack. You could probably do something like that and then you might get the same answer as well. So again, just goes to show that many techniques work, but as you can see, at least from the 3 that I chose and demonstrated, the simple U substitution was the quickest, okay, and the most efficient, in my opinion, okay? For this partial fraction decomposition, look at all this stuff that I had to do, and same as trig sub. It wasn't that much, but it definitely took more time than the time that I took to do this, especially if you're on a time test, then every second matters. So pick the most efficient technique.